Hello and welcome to Security, Cryptography, whatever. My name is David.
I'm Deirdre.
I'm Thomas.
Yeah.
And with us today we have special guest Alex Gaynor. How are you doing, Alex?
I'm doing great. I'm excited to be here. Thanks for having me.
Woo!
Alex, I would say, has been a long-time listener, but I'm pretty sure he's too smart to actually listen to us. But we have wanted to get him on the podcast for a while to talk about a number of things. And we conveniently find him at a break in his career. And so thought now would be a good time to talk about why in the world the FTC would want to hire some sort of technologist. So why don't you say maybe a little bit about yourself and how you ended up at the FTC?
Yeah, so I am by background a kind of, we'll call it mixed specialization software engineer. And from 2022 to mid-2024, I worked at the U.S. Federal Trade Commission as the Deputy Chief Technologist. And so you asked how I got there. I mean, the shortest answer maybe is that I ran into somebody who'd been a colleague in my first stint in government back in 2016 or so, and she had just become the chief technologist at the FTC, and perhaps knowing me better than I know myself, said, "You've got to come here. Like, I think you will enjoy this. This is like an opportunity to do like very interesting things. You will be good at this." And I had kind of just wrapped up a project I was working on, so I needed to find something new to do anyways, and I jumped in.
So your first time in government?
No, so my first stint in government was 2015, 2016, right kind of at the founding of the U.S. Digital Service, which was the group created kind of after the Healthcare.gov crisis and recovery efforts, with basically the mission of bringing more folks in who had kind of hands-on, particularly private sector technology experience to help the government deliver and the services it delivers and the kind of services it operates better.
Yeah.
I took a couple of years away from the federal government in between and then came back in 2021.
And the digital service did like login.gov and things like that. They did other things, but that's one of the things I'm like, ooh, this is nice.
Yeah, login.gov was a joint project between USDS and sister agency 18F.
So what is the difference between USDS and 18F? Because I see them both on GitHub.
Yeah, so I mean, you use the present tense is, which I think is much harder to speak to.
Okay, let's say
but in the past,
DS has a new name now.
In the past tense, the difference I would have said is 18F overwhelmingly works on kind of greenfield projects that they are brought in and asked to work on, whereas USDS gets sent to places to make sure kind of in-progress projects become successful. So this is sometimes described as 18F is the vampire and USDS is Kool-Aid Man.
Okay. Vampire? Okay.
Vampires have to be invited into your home.
I see. I was like, they suck the blood out of some executive branch place? Oh, that's very
No,
appealing.
they have to be invited in, whereas like the Kool-Aid Man slams down the wall.
Oh, okay.
Am I crazy, or did DS happen because of the Obamacare rollout? Was it like that?
Yes.
Yeah.
There's this kind of Healthcare.gov catastrophe. A bunch of kind of folks with private sector SRE experience come out to help put that together. And then, at least in the pop culture telling, the president says, "Why did none of these people work for me?" And this is kind of the opportunity for folks who were already in the government who had been trying to get this thing off the ground, like Jen Polka, to say, "Yep, we've got the plans ready to go. Like, just give us permission to start hiring."
And was that like we can talk more about this. Is that like the root cause of like why Healthcare.gov, the like first version, was basically a shit show because it had bad like site reliability engineering and load balancing and handling of traffic and all that sort of stuff?
I mean, root cause is maybe it's hard to like, you know, if you did like the 5 whys exercise, you'd be like 15 whys deep and probably still not a singular root cause. But to the extent there is a single cause, it was that it was a system designed by dozens of contractors, which had never processed so much as like a test transaction before it went live. You know, it had never been load tested. It had not really been... It had been developed the way you might develop like the landing page for some subcomponent of the government that like posts a website with like news announcements and like bios for its executives, not like the way you would architect like a consumer service that like does many transactions per second.
This hurts my soul.
Yeah.
Just given the timing, I would have assumed that would have been like one of the first times the U.S. government was ever in a position to like stand up, a continental scale SaaS, basically.
Yes, in many respects, it's kind of the first one, and particularly the first one that has like that degree of public attention on it, right? Despite Obamacare becoming law in, I want to say 2010 or 2011, this website doesn't go live until 2013. So like, it's had this really extended rollout period in which healthcare, the ACA is becoming more controversial. There's just a lot more interest on it. Incidentally, the website launches kind of during Ted Cruz's filibuster that shuts down the government. So at first people don't notice that the website doesn't work. And then the filibuster ends and like the website is still not working.
The chronology of this is kind of breaking my brain. And like, I forget that Healthcare.gov didn't roll out until after the re-election.
Yeah.
Anyways, FTC versus U.S. Digital Service, what was the working environment?
So I mean, at USDS, the thing you were being tasked to do was go work with different government agencies to help them deliver a software project successfully, taking kind of the combination of what you learned about what the government is trying to execute on, what the policy goal is, and what you know about delivering successful technology projects, mostly from a private sector background. In contrast, the role of a technical person at the FTC is not to help the FTC build software. Okay. It is to help the FTC's leadership and attorneys and economists understand how technology works, and sometimes kind of the dynamics of technology markets in order to execute on the agency's mission, which is consumer protection and competition law enforcement.
Can we talk Oracle v. Google? Were you there for Oracle v. Google?
I was not at the FTC for that.
Damn it.
I was very much following Oracle v. Google, and in fact, I organized an amicus brief of former government software engineers.
And for context, this was all about Android and Java APIs, and I think we technologists became very much fans of the main judge, who taught himself Java and programming and had informed opinions about, being able to copyright and sue over, the API for an ad function or something like that. So, but yeah, not that one, but but other cases. Is there a favorite FTC related technology case or thing that you worked on while you were there?
So, I mean, it's always hard to kind of say favorite. Like, I could pick, like, maybe three favorites. One that I particularly enjoyed that is maybe on topic for this podcast is I worked on a case that the FTC ultimately settled against Mastercard, which was about the enforcement of something called the Durbin Amendment, which basically says if you have a debit card in the U.S., your issuer has to make it possible to process transactions on multiple networks.
Right.
So, like, you have a Mastercard brand debit card, but there's also a second network on that card, which is often referred to as the back of card network, and it has to be able to process transactions as well. And what the FTC alleged is that basically Mastercard had made it more difficult to have transactions from a digital wallet like Android Pay or Apple Pay be processed on the back of card network because of how tokenization worked. Your Android or Apple Pay wallet doesn't actually store the credit card number. It stores a temporary token, and there is effectively no way for a back of card network to translate the token into the actual card number to send to your bank.
Oh, that's fascinating. So something that almost, from my perspective, seems like a way to separate responsibilities and make sure that something is not compromised. Like if this was broken on your phone, someone could steal your credit card number. And so the way that this kind of works is it's sort of ephemeral use, right? But that ended up being breaking the law.
Yeah, I mean, it didn't have to be. So, MasterCard already had systems where for other forms of transactions, including tokenized transactions, back of card networks could call out to them and basically, get this transaction verified and, and get the actual card number to be sent to the issuer. The issue was for certain Apple Pay, Android Pay transactions, they did not, which, in addition to this law saying there has to be multiple networks, it said if you're a network, you're not allowed to make it harder for somebody to have multiple networks. And so, I mean, this is, one of those cases that's on my short list of things were fun because, figuring out, did this violate the law involved a lot of learning about how debit card transactions are processed, going to kind of each step in the process and like asking people, please explain to me merchant, Stripe, bank, like explain to me how you understand how the data is flowing through the systems, and like, finding write-ups of like the cryptography involved in these systems, what is a token? So like, it was just kind of a lot of fun for that reason.
I didn't even know there was a backup card thing.
No.
I
mean, there's no reason to know unless you are basically a merchant, and merchants like this because it gives competition between the debit card networks, and that gets them lower rates.
Yeah. And like everyone who has gone to a place and they're like, no, we do not take American Express because the fees are too high, can understand why you want multiple options to execute a transaction because of you don't want to get locked in or you don't want to get locked out.
Yeah.
Do we have an inkling of like how multiple implementations of this sort of solution, which is Apple and Android, or Android and Google, Apple and Google, arrived at the same solution, which is not well supporting the backup card network? Is it just like, oh, we didn't realize and we copied each other? Or was there something more like, let's see if we can get away with this until we don't have to?
Yeah, so I mean, I think Apple and Google were like ambivalent about this, right? They don't have a stake in this one way, but like my recollection / understanding is Apple rolled out Apple Pay first and kind of got a handful of credit and debit card networks on, and they kind of, they designed the interface kind of between themselves, and not kind of what MasterCard or Visa's relationship with other networks would be. I mean, it's also the case that these systems all look slightly different in different countries. Like it's there's just kind of different network layers in different countries. Like I believe Canada has like approximately one network, and like everything just goes directly to your bank more or less.
Okay.
Don't quote me on that, but that's my recollection.
Cool. All right. So that was one. Do you have the other two of your top three?
Yeah. So the other thing that I really enjoyed working on was the FTC does consumer protection cases, which include data security, which is largely, though not exclusively, kind of data breaches. And I got to work on kind of a series of cases there, primarily focused on kind of what the terms of settlements were, so that when companies settle these cases, they basically agree to injunctive relief, that is to say, like, relief that changes their behavior, and that they agree that they will, from now on, run a reasonable security program that kind of effectively protects consumers' information, and has, they will study the risks and like implement safeguards they find necessary, but also the FTC will enumerate, generally half a dozen or so particular safeguards. And I worked basically across a series of those to introduce kind of more modern best practices, like you will not just have MFA, you will have phishing resilient MFA, right? You're going to use something like, we don't write like WebAuthn or, if you wanted X509 certificates, but like it has to be phishing resilient. There's a case that requires the company to manage their infrastructure with infrastructure as code, basically, and actually get code review on infrastructure changes. There's kind of like a whole series of these kind of modernization things. I worked with attorneys to kind of not just get into individual cases, but really get into the kind of toolkit for like when this is on point for the case, this is kind of the best in class thing we're looking for.
These are like the commercial equivalents of consent decrees then? They're like negotiated settlements enforced by...
Yes. The FTC occasionally litigates these cases, but the vast majority of them are settled between the FTC and the company.
Do you feel strongly that those are being well enforced and well followed in practice?
I think so. There's kind of a non-trivial lag time between when a thing ends up in a consent decree and when you would actually find out if it's if they're not actually following their obligations. But there was some good anecdotal evidence that like people were paying attention, like just in the course of negotiating one of these before the kind of ink had been signed, like one company was explaining to us, so they'd purchased tens of thousands of YubiKeys.
Yeah.
So like I think at the very least, at least that company got the message.
Purchasing the YubiKey is one thing.
Well,
Hey, like, come on. This is exciting. This is nice.
dare to dream they actually deployed them.
Yeah. Okay, and what's number 3?
Number 3 was probably the FTC's lawsuit against Meta, alleging unlawful monopolization, and that was particularly interesting. So that case is kind of there's like a ton of like deeply like technical economic questions about like what market like Meta's products are in.
Yeah.
But one of what are called if you're defending one of these cases, you can assert what are called pro-competitive benefits or justifications, basically saying, notwithstanding the bad stuff you accused me of, actually this was good for this was good for competition. And in this case in particular, Meta alleges that their acquisitions of Instagram and WhatsApp were necessary for them to be able to scale because of the kind of infrastructure that Meta provided to them. And so that was just like a ton of fun to like dive into. Okay, what were these companies, now kind of a while ago, what were their pre-acquisition infrastructure like? What was their migration to Meta's infrastructure like? What kinds of metrics exist? And like I'm a little limited in how much I can talk about this because it's still in trial now.
Yep.
So there will be more things in the news in the weeks to come about this. But yeah, that was just like a blast, and like particularly Instagram's tech stack at the time of the acquisition, and I mean through to today, as far as I know, is like Python and Django, which are
really
yeah,
holy shit,
which are like those are like I'm mostly emeritus, but like I was a core developer of both of those at the relevant time. So like it was like it's cool to like kind of be looking at the probably the largest Django website on the internet.
Yeah.
I was on a team that did an assessment of that code base a long, long time ago. So
Of the Instagram code base?
yeah, this is like a thing I don't understand about. It's a thing I don't understand about the discourse about the trial here. It's just like
Discourse.
Instagram when Meta bought them is not Instagram now. Like they're different products. Like there was like a nascent kind of social. As I remember, there was like a nascent, social network thing going on with Instagram when they got bought, but they are a social network now, right? Like,
Sure.
And to the extent that happened, Meta made them that.
I mean, so the exact facts of these are just like a huge question of the case. Like, I think what I would tell you is I've been sitting in court every day for like the past 3 weeks, kind of just listening to the arguments, and
Because you're out of the FTC now, so
Yes, I'm
you're
no
just
longer
a
there,
regular dude hanging out in court.
as one does. But I think
who knows who you might see in that courtroom.
I think the through line is basically Meta was very much struggling with getting Facebook to be popular on mobile, kind of in roughly this like 2011, 2012 period. Like you may recall, like they had initially rolled out an HTML5 mobile app that was like slow and like not a positive user experience. And so this kind of provided a window for Instagram to build an alternative social platform on mobile that was like really mobile first, that used kind of photos as the centerpiece of communicating with your friends and family, and Meta acquired them in an effort to prevent them from doing that. I mean, it's interesting that you say, like, obviously Instagram is a social network today, because a key thing Meta argues in this case is that people maybe think of it that way, but actually what Instagram is mostly is it's like a video platform. Like you go there to watch videos the way you might on TikTok or YouTube Shorts.
Well, that's not true.
All right, well, you can let them know.
Yeah. One of the things that I find interesting about the Instagram wouldn't be what it is today without Meta argument is that the advertising solutions that Meta brought to them, or then Facebook, into Instagram, the platform, seems to actually have like really mattered, because like you could make an argument that like Instagram would have been pretty big even if they hadn't been acquired, if they figured out their infra and they were able to scale and all that sort of stuff. But like it does seem that that is like one of the things that really seems to make a difference, at least from the business side and the user experience of the advertising solutions and stuff like that. So I find that kind of plausible. The other stuff I'm just sort of like, yeah, maybe.
So kind of the ability to monetize via advertising is definitely also another thing Meta has claimed as a benefit of the transaction. It's interesting. Kevin Systrom, who is kind of one of the two founders of Instagram and was the CEO, testified the other week that like they basically had like shown designs to the board for advertising on Instagram pre-acquisition that look remarkably like Instagram's ads today. So it's my impression was, at least in his mind, like they would have been able to execute on this stuff the same. From a kind of consumer perspective, one of I think the FTC has been pushing is that by kind of being owned by Meta and by being kind of together forming a monopoly in this, what the FTC calls the personal social networking services market, Meta is able to raise what's called the ad load, basically the percentage of items in your feed that are ads, that higher than they would be able to with kind of independent services that have to compete for users more.
What's interesting is that they also acquired WhatsApp, and WhatsApp is part of this case as well. And like,
correct.
It seems from the testimony so far, like the founders of WhatsApp were like, no ads, no ad injections ever. And like, so far that seems to have been the case, but not without like the parent company, Meta, really trying to figure out a way to make that work. And it still hasn't worked yet. And so it's hard to like argue what the benefit has been for WhatsApp by being acquired by Meta.
Yeah, that's a great point, because WhatsApp is a slightly different case. The FTC does not say that that WhatsApp is a social network in the same way. What they say is a thing that we had seen happen at this time period is several mobile messengers in Asia had pivoted from being just mobile messengers to also being social networks. So Kakao and Line and WeChat, all in different countries. And basically, Meta was afraid that WhatsApp was positioned to do the exact same thing because of their kind of giant and fast-growing user base. And so they acquired them to prevent them from executing this pivot. And WhatsApp founders, I think the testimony is pretty clear, like would not have wanted to like kind of do any features. They did not want ads. And then, so part of the case is just like, well, it would, as an independent company, it would have had to make money eventually. Like, would investors have basically pushed WhatsApp to monetize in some way, right? Develop new features, sell stickers, probably roll out more social features, because that gets you more kind of time in app.
Yeah, and like, didn't they used to have like $199 a year or something like that? They had like a really, really low service fee to use WhatsApp for indefinite messaging or data or whatever, and then they got rid of that. Yeah,
it varied a bit by country. Like my impression is they were kind of constantly experimenting with it, but at least in countries like the U.S., they were charging, I believe, $1 a year, and then Meta got kind of rid of that fee kind of across the board, which they claim is a benefit to consumers.
It is, and I wonder if this is also a function of the zero interest rate era that all of this happened in, and if this were another time and place, like that just would not be a thing anymore. But on the argument that like the multi, like the everything app future that WhatsApp could have been, a la WeChat and the others, I've heard an argument independent of the arguments made in this case that the American tech app culture just completely splintered into, you have an app for calling a car, you have your Uber, you have an app for ordering your food, you have an app for uploading your photos, you have an app for messaging your friends, you have an app for all the things, and that had already happened. And so like the American tech user on mobile platforms was just sort of like didn't care about an everything app like you might in another country, another market. And therefore, maybe if you tried to make WhatsApp the everything app and tried to make X the everything app, it just wasn't going to fly because everyone already has their app for that thing and they don't care that much. Maybe you get some usage. But now I'm hearing about the argument is like, well, it might have been, and Meta bought it and stopped it in its cradle. And now I'm wondering what could have been.
Yeah, I mean, what could have been is kind of definitely at the heart of this case. It's interesting, in a separate lawsuit the Department of Justice has against Apple, and another antitrust lawsuit, the Department of Justice alleges that Apple has basically worked hard to prevent everything apps because those would kind of compete with Apple's control of the platform.
Fascinating.
I am less conversant in the exact market dynamics of WhatsApp than I am kind of the pure tech infrastructure pieces, but
Yeah.
What is the FTC? What is the deputy technologist role at the FTC with regards to these cases? What's that work like?
Yeah. So, I mean, as a deputy CTO, my job was kind of partially management, leading the team, hiring, kind of all of that set of stuff, and partially being an individual contributor on these cases. And basically, I'll focus on the IC part because the manager part's probably not so different than being a manager anywhere else. But as an IC on one of these cases, really it's your job to kind of understand what is the case the lawyers are trying to investigate or litigate, and how technology interplays with that, and how you can use your understanding of the technology to better inform what the lawyers are attempting to do. So, if we think about just the full life cycle of a case, kind of before an investigation has begun, you've got kind of what we call target spotting, identifying, things, whether it's in the news or in security research that may indicate possible violations of laws. So you're kind of, consuming your tech media and seeing, hey, from what I know about the law, what of these might be of interest to lawyers? Then as kind of a case is going on, you're kind of the first step is or an early step is it's called a CID, civil investigative demand. It's a subpoena, right? You're helping attorneys craft what are the types of documents requesting, what are the questions we're looking for answers to, and helping everybody use technically precise language so that you're getting exactly what you want. You're not missing anything. You're knowing to say, hey, we want this data from your issue tracker, not just your email inboxes, for example. You're helping review those documents. As you're getting, you've made a decision that you think this does violate the law. You're helping draft the complaint, making sure the kind of technical points are accurate. In a settled case, you're helping kind of identify what are the remedies you want. What are you asking for in the settlement? You're often kind of getting on the phone with the opposing counsel. Maybe in a security case, you might be on the phone with the company's CISO, where they're saying, hey, you asked for XYZ, but we can't really do that, for this reason. And you're saying, okay, if we tweak the language like this, would that work for you? So, you're just working alongside the lawyers, really through the life cycle of the case to make sure it's informed by, what the technology is, how the technology works.
For the meta case, what is the FTC's technical staffing of that look like? Not lawyers, but technologists that are actually guiding and reviewing discovery and things like that. Yeah.
So there were at peak 2 or 3 of us on the case, and every technologist on our team was on multiple cases. So.
Oh wow.
And then in the meta case in particular, the FTC also has kind of 2 outside experts they retained so expert testify in court, will draft a report explaining their findings and kind of all that. You've written about going through this process recently, Thomas. So in that case, there was kind of outside folks as well. And so in Meta, we were also supporting kind of the experts through the process.
So do you get to be one of the first people to get discovery or to see some of the technical discovery? Do you get to see source code and other cool, possible juicy things?
There was a ton of interesting things. Occasionally you'd see source code in an email or in a chat message. It's mostly not a lot of source code. But yeah, there's just tons of fascinating emails. Debating the pros and cons of migrating between different internal databases and just lots of I don't know if you're a nerd about this stuff, lots of cool stuff.
Nice.
A lot of those emails and stuff end up being public eventually, and then because there's that Twitter account that's tech emails or whatever that just posts random emails that have come out in court between Steve Jobs and and like Larry Page at Google or whatever.
Yeah, the ones that are used in evidence in the case will mostly make their way into the public, but I mean the meta case has millions of documents that have been produced by both the parties and the third parties. In antitrust cases, you have other companies that may or may not be kind of in the market also producing documents.
Right.
So, you go through kind of the funnel of, all right, which of these are at all interesting, which of these, maybe support one side's case, and then which will actually get used with a witness. A witness, maybe we'll see like a dozen documents. So, like, this is a tight funnel. And then, the public ones are obviously redacted. If there's competitively sensitive things or, names and stuff like that. But yeah, so there's a funnel, but like in some sense, the most interesting or most important ones, yeah, you actually get to see.
And then was there anything that like you worked on and then it determined, we want like a technologist to look at this, and then actually, you know what, like this behavior is fine. There's nothing here.
Yeah, I mean it's difficult to it's much more difficult to talk about those because you might
want to change your mind later.
Well, no, not even that. You think about this the same way like a law enforcement agency does. Like you don't talk about uncharged conduct because that's prejudicial, right? If you talk about charged conduct because the other party gets the chance to, defend themselves in court. They get the chance to clear their name. But if you talk about uncharged conduct, then like they never get to go to court and prove like that I didn't do that bad thing. It's like I can't really talk about all the times we looked at a thing and we said, this doesn't seem bad to us, or more like working collaboration with lawyers. We didn't seem bad, but there's absolutely cases where like a better understanding of the technology or the norms or the market was like, we would not be able to bring this case and win.
All right.
Is there anything else we should ask you about the FTC?
No, I mean, I would just say, like, it was a fantastic job. If you were the kind of person who's, like, interested in the law and also is interested in kind of, like, diving into different areas of technology, like, is a fantastic job.
Nice.
So let's talk about open source, because I think there's a lot of things to talk about there, starting with how you have @Alex on GitHub, which I think is impressive because I thought I was like somewhat early on GitHub in that I created @Daydrian in 2010, I think. But I believe you have me beat there as well with just your first name.
Yeah, I mean, I guess all of my stories start with, having friends who like pointed out good things, but I had a friend who like very much pushed me. I'd been programming like a year at this point. It was like very much pushed me to like apply for the GitHub beta.
Oh.
So like
there was a beta?
That was.
Yeah, I didn't know there was a beta.
I think so. There was definitely a point where like you had to apply to like get an account. Like there's a wait list. So like that's how I got Alex.
And I think most people know you, or if they don't know you, have interacted with you indirectly when they've pip installed cryptography. Or perhaps pip installed certify, or actually, I'm kind of remiss to say pip because every time I look at the Python ecosystem, the packaging story has changed. Maybe they're pi-ending something.
It's all UV now, right?
I've never even heard of that.
I've heard of that.
UV is kind of
He looks so alarmed.
I just feel like every day I spend as a product manager, I get a little bit dumber.
Yeah.
UV is good stuff. It's from the same folks who made Rough, which is kind of the new, much faster linting engine. UV is kind of a reimagined Python packaging experience. It's implemented in Rust. It's it's very fast.
I like it.
Yeah.
I don't know what Rough is. I don't write Python no more. That's not true. I wrote some Python today.
Let's loop back to Rust later, but first, so like, what is the cryptography package, and why are you maintaining it, and are you a cryptographer?
I am not a cryptographer. I am, somewhere on the spectrum of like cryptography engineer, which is to say like, I think mostly about, how are how are these primitives used? Like, what kind of APIs make it more likely for users to use them successfully? Like, the kind of the ecosystem and API design side of things. Like, I'm very fortunate that my co-maintainer, Paul Kerr, has like a much stronger cryptography background, and like he does understand what a lattice is, I'm pretty sure, whereas I do not. But so what is it?
Do you really not know what a lattice is?
No.
Deirdre,
fine.
he should know what a lattice is.
No, it's fine. It's like
Fine.
secretly,
Thing
the
you
lattice
grow
based.
plants on.
Yes. It's like, here's a secret. All the lattice-based cryptography that we're using does not actually implement any lattices. So you're fine. You're good.
Outstanding.
I think we've had people who've literally published at crypto on this show who have been like, I'm not a cryptographer. So
I am less of a cryptographer than they are, I'm prepared to say. But anyway, we aim to be kind of a general purpose cryptography library for Python. So like the place you would go if you want to like encrypt something with AES, or like do an ECDH key exchange, or like also kind of a lot of the kind of file formats that exist in the cryptography cinematic universe, like X509 certificates, or like PKCS 12 like bundles, that sort of thing. And then we also kind of under the same, we have this Python Cryptographic Authority brand. Under that brand, we also maintain Pineapple, which is Python bindings to, well, nowadays it's libsodium, but the library formerly known as DJB's NaCl, not pronounced salt. And we also maintain PyOpenSSL for our eternal
I
shame.
didn't know this.
Yeah, and as well as the bcrypt Python library. But like cryptography is kind of like the flagship library for no other reason than it's got the obvious name.
You're doing more than like I would take on like as a software maintainer, especially all the X509 stuff. And I think like you have some more stories about being motivated to re-implement how these things are implemented, partly because of some of that sort of stuff. This is a great service because this is this is stuff that people doing software, they're just trying to get the cryptography part working as part of the rest of their software project. They have to interact with. And like all of us like highfalutin crypto people who just want to do some nice math and just make it go burr on the computer, they don't want to deal with the X509 part. But the real people just trying to deploy some shit that uses cryptography, they need to deal with things like X509. So thank you for helping them do that securely.
Pre-cryptography, like I remember it was like circa 2011. Like I don't know if you guys had started cryptography yet or if it was still in its early days, but like trying to just like make an HTTPS connection in Python was like fucking impossible. And you had to like the wheels didn't yet or barely existed, and so you like had to like apt-get install OpenSSL and like hope that PyOpenSSL worked, and like probably got GCC errors, and that was a mess.
I have a
The world
question.
is much better now.
Yes.
I've been seeing this for like 20 years now. What's a wheel?
Okay, so wheel is...
I've asked Alex this before.
the name itself is an inside joke. It is a binary distribution of a Python package that is precompiled for some particular platform.
Okay.
So like, you pip install cryptography on Mac OS, Windows, or Linux, you will get like some .so that we have already compiled for you, and you will like not have to build it on your computer.
It just means you don't need the depths to build the library.
Yeah.
Okay.
Well, yeah. Particularly, you don't need the system dependencies. You don't need GCC.
Gotcha.
And yeah, historically compiling like Python extension modules is like a very fragile thing, and so like it's a huge performance and user experience boon to like the vast majority of users. Like separately, I think there's like a big security question in like shipping like .sos, or like it's effectively unauditable that they match up with their original source. But
was there a I might be confusing a debate about this in crates.io and Rustland and in Python land. Was there a big debate about this recently, or am I just? I think was it for cryptography, for Python cryptography? About shipping binaries?
I don't think there's been a big debate in the Python. Like the Python community has been pretty accepting of these. There was a fracas in the Rust ecosystem.
Yeah, I think that's
a year or two ago because Rust does not have pre-built binary distribution as part of like the crates.io ecosystem, but there was a package that like basically like in their source distribution was like, I have just put a .so in here and I will use it if it looks like the platform is correct for it. As a performance optimization. Yes, there's much gnashing of teeth.
Well, it violates their security model that if all CPU cycles are spent on the compiler, then none of it can be spent on an unsafe program.
Anyway. I have lots of other formal methods languages that spend way more on CPU than Rust C. I will not take this slander.
But wait a minute, what was the inside joke about the name Wheel?
Okay.
Wheel.
So most Python naming is downstream of like Monty Python. So PyPI, the Python package index, which was originally known as the cheese shop, and you get wheels of cheese from the cheese shop.
Okay. I thought everything was someone just named something Python and then everyone went with the snake, motif. But no, apparently
No, it's
You know what's
Monty
funny?
Python.
What's funny is I was exactly this many minutes old when I got the Monty Python to Python thing just now. It occurred, oh, that's why they're doing everything with Monty Python.
Yeah.
Oh, me too.
It all makes so much more sense. It's the worst.
Happy to be of service. Happy to be of service.
Okay, so we've touched on this, but when you started Cryptography and took over some of this stuff, almost all of this was Python wrapping C, right? Or calling out to C. And now a lot of that has evolved away to a lot of Rust, right?
Yeah, so when we started Cryptography back in 2013 or so, it was basically all wrapping what we called backends. At the time, we had this idea that we'd support multiple backends. So for a while, we supported OpenSSL as well as Common Crypto, the Apple system cryptography libraries. Those were all kind of binding between Python and C. So it was technically all Python code, but it was the kind of Python code where you've got pointers and can have use after free vulnerabilities.
Oh,
and then I think it was back in roughly 2021, we kind of took our first steps of diving into porting some of that kind of binding code from kind of Python C hybrid to Rust, and nowadays we dropped the common crypto, so we only have OpenSSL as a backend, but now the chain looks like you've got Python calling into a Rust extension module, which uses the Rust OpenSSL Rust library, which still binds to OpenSSL at the end of the day. For all of the kind of things we think of it kind of as cryptography, so AES, RSA, coming soon, MLChem, that family stuff. But a lot of the things that we think of as more like file format parsing, like parsing X509 certificates, a lot of that stuff we used to use OpenSSL for, and now we just have our own Rust implementations of that. We've taken it, including parsing, keys from PEM files and things like that. We've taken that away from OpenSSL.
Nice. Okay. Because for some reason I thought you had literally we're shipping all of it and not just linking out to OpenSSL for those parts, and rewritten all of a pile of C with a pile of Rust. It's okay, well, we wrote some of the most gnarly surface area that we control with some Rust. So, okay, I get it.
Yeah, so we have a lot of, tens of thousands of lines, or maybe 20,000 lines of Rust code these days. So it's non-trivial, but we're still reliant on kind of OpenSSL, and we will also support LibreSSL and Boring SSL and AWS-LC. But for now, kind of all of our official distributions, and I'm sure 99% of our users are kind of
what about
using OpenSSL.
Russells?
Well, yeah, so what about something else? So I think we have a lot of interest in what a post-OpenSSL world looks like for us. Russells itself is, it's mostly a TLS library. So we need to use kind of the underlying cryptography library, whether it's, if it's a Rust crypto or AWS-LC or something like that. We have a lot of interest in that, in what something like that looks like. We're not super happy consumers of OpenSSL. There's a lot of logistics between here and there, and particularly figuring out how to manage the kind of conflicting needs of many of our downstreams. So using kind of OpenSSL as the lowest common denominator means, AWS can just drop in AWS-LC, and Google will drop in Boring SSL, and Red Hat can use it with the system OpenSSL they've done FIPS certification on. And so, kind of any move we make away from this is going to be disruptive to somebody. So we have kind of the question before us of how do we come up with a plan that mitigates that?
Yeah.
Is there any notion of upstreaming the 20,000 lines of Rust that you guys wrote?
Upstreaming to who?
Yeah.
To OpenSSL?
Right. The path that you guys are cutting through OpenSSL is disproportionately the stuff that people care about, right? Like the reason you're doing this is because people make TLS connections from. It's what everyone uses OpenSSL for.
Yeah, well, I want to hang like a little asterisk on that, like in the sense like I do not think we have a good understanding what OpenSSL uses. I'm sure by volume, like the number one thing people do with it is like they use it with Apache or curl to like make or like receive HTTPS connections. Like I'm sure that just has to be right. I think by volume of participants in like the OpenSSL ecosystem, there's actually a huge amount of weight on like other use cases, just in terms of who participates in the OpenSSL development process. It's actually weighted, I think, probably far from people who just want to make TLS connections. But like if the OpenSSL community were interested in upstreaming some of this, it's absolutely a conversation we'd had. Part of it is like we've made pretty different design decisions than them, and it's not super clear how you map like a backwards compatibility path. Like fact of their X509 and really ASN1 APIs in general is there's a lot of small allocations. Like you have all of these subfields on an X509 certificate, and many different like tiny strings, and like each one gets its own heap allocation. Whereas the approach we've taken is we just keep around a reference to kind of the original byte string, and everything is just pointers back into that byte string. We have a lot of confidence that's safe, like because Rust, but like it's not super clear how you would navigate a backwards compatible path between those.
Got it.
But like we've structured most of these things as like the standalone Rust crates in our source tree, like including like we have an X509 path builder that's implemented in Rust on top of these structures. Like
Nice.
it like we if there was interest, like we could make these things reusable and like designed for somebody else. Like they're kind of minimally structured for that now.
I will say that like the fact that you have your separate X509 parsing set and all these sort of things will be good. That the new MLChem and MLDSA certificate stuff that is coming out of IETF, you get to make your own choices independent of OpenSSL about how you parse those, and that's a good thing.
Yeah, I mean, if you look at the MLChem design discussion issue we have open, there's like pretty strong consensus. Obviously, the only like formats you should parse are like seed only.
Yeah.
No like expanded form.
Thank God.
Yeah.
A chunk of this code it's not like all just buried in the internals of the cryptography repo. It's like Alex / my super fun ASN1 parser or something like that, right?
Yeah,
like
yeah.
it is a Rust library. It's just the stuff to jam it, wrap C around it, or wrap Python around it is what's.
Yeah, the kind of baseline dir library is its own Rust ASN1 library that it's on crates.io. Like that is designed for reuse, and Signal uses it, which is like one of the coolest things I get to say.
Oh, nice.
So yeah, like that part, but like the part where like we then use that to define like X509 structures is not is not really it's not on crates.io. It's not structured for reuse at the moment.
Okay.
Are you getting paid for any of this?
Early on, Paul and I got a bunch of time from our employers like to basically work on this, but it's actually been quite a while since either of us like so much as used cryptography for our day jobs, much less got paid to work on it. So like this has been for a while now a labor of love. It's a labor of love and a labor of ideology. In the sense that like we've become a very popular thing, and like we take that seriously both as an obligation to users, but also as an opportunity to improve things.
Yeah.
So like we want to we want to be the library that pushes forward what's possible, and by being like a very popular thing, we think we've made it materially easier for like other projects to use Rust and Python extensions, for example, by like being willing to take some of the user frustration and push through that.
And I think you experienced a lot of user frustration. Was it when you ported a bunch of stuff to Rust and you had to like basically drop support on certain platforms or something like that with a major version or some version upgrade. And they were like, this doesn't work anymore on my like extremely obscure platform that hasn't updated Python in like 15 years. And you had to just sort of be like, we're sticking to our guns, folks. Like, it's going to be better for everybody.
Yeah, when we shipped the first release that contained any kind of Rust build integration at all, that was definitely kind of a point of frustration for a lot of users. And like, we get why. Like, people had the experience of breaking overnight. There were also like subtle things like an assumption that our versioning scheme matched semantic versioning, which it didn't. So there's kind of a lot under the surface there. Since kind of we worked through that feedback, in particular, Alpine Linux distributions got wheel support. That did not exist at the time. So like that was probably the biggest cohort of users who went from like this pip installs correctly to what is this nonsense about I don't have Rust C on my path.
Yeah.
So like since support's been introduced for Alpine wheels, I think experience overall has been better, and I think there is a recognition that kind of more marginal platforms, your AIXs, your PA risks, to a certain extent, like if the maintainer of your platform is not willing to invest in it, there's just, you can't really be expecting open source maintainers who have, never so much as seen a system running on your CPU or your operating system to be the ones to do the work that, IBM or whoever isn't.
Yeah. What's your, like, it's just the two of you, right? Like, what's your CI in for, like, to try to maintain support on such a wide platform or does PyPy take care of a lot of that for you?
Yeah. So we are huge believers in CI. We often joke that we're mostly a CI engineering project that happens to have a cryptography library. Yeah. So we run... nowadays, we're kind of exclusively on GitHub Actions, entirely on their hosted runners, but we have, I think it's roughly 60 builds in the matrix of, different Python versions, different OpenSSL versions, different Linux distributions, Windows, Mac OS. So like, it's mostly just like kind of a big matrix. And like the worst part is like, we have lots of things that like we would like to do that, we haven't done. Like it would be very, very helpful to run builds in a Intel SDE, which basically lets you simulate different CPU feature sets and like make sure everything is correct on like, do you have AVX 512 or not? Like, right, all of those variations. Because I mean, part of this is like we just think we're responsible for the end product, so like we don't take for granted that like OpenSSL has implemented the primitives correctly. Like we take which proof, like with this collection of like test vectors, and we run it against every one of these build matrices to make sure we're trying to do our best to do right by our users.
One of very few projects ever to have operationalized which proof.
That's not true. There's a lot of projects that have operationalized that you just might not hear about. And it might be just one or two of the test vectors.
Yeah.
Like, that's actually interesting because, like, what happens if your connection to your dependency, which is mostly OpenSSL, like, breaks something and your tests against it don't pass, and, like, you just turn off a feature, or you ship it's like this has got broken, or you don't or like what do you do?
Yeah, so say new release of OpenSSL comes out, it has something broken. This happens significantly less frequently these days, if for no other reason than we have kind of a bot that has us testing nightly against like whatever the moved kind of head of OpenSSL is.
Oh, good. Okay.
So like
so are you basically running CI for OpenSSL?
I mean, they have a non-trivial matrix of their own. I believe I think we're very disciplined, in particular, at adding regression tests, which I don't think OpenSSL always is. But it's there's a little bit of a snake eating its own tail, because they also run our tests in their own CI, but kind of only on one platform. But yeah, in a situation where like we identify a breakage, like first thing is we're not going to ship a release where like our wheels statically link a copy of OpenSSL, so we're not going to ship a release with that. We're going to report the bug to them. We're going to try to get some action taken if a bug fix release is not forthcoming or something like that, we might take the step of, kind of pulling, can we detect the circumstance of this bug kind of at our API layer and take some sort of corrective action or error out early.
That's good. So you have a early detection and constructive relationship with your dependency and somewhat vice versa. So you're able to avoid this as much as possible.
Yeah.
That's great. And now I'm looking at your CI and your custom runners and all of your infrastructure on GitHub. Now I'm curious.
Historically, it was like a lot more complicated. Like before GitHub had hosted ARM64 runners, or before they had like M1 CPUs. Like we ran our own. We for a while we were running our own Kubernetes cluster of like ARM64 Linux to like provide runners and
like a Mac Mini in the closet or something.
And then at various other points we've had kind of other hosted CI providers, but for the last couple of years we've settled on GitHub Actions.
They pretty much have everything you need. It's pretty awesome. Thank you, GitHub Infra.
And they graciously provide us an increase on the standard amount of like free concurrency. So we're very otherwise I think running kind of 60 concurrent builds on every
would cost you a lot of money.
Well, less so the money and more just like it would give us such a long feedback cycle on pull requests that I think it would really hamper kind of motivation and productivity.
Yeah. So they, instead of you getting rate limited on the regular rate limits, they're just sort of like letting you not get rate limited.
We have, I don't know what the actual threshold is, but we have higher than normal pre-concurrency.
That's awesome. So that sounds like a nice perk that you don't have to pay for yourselves to run your open source project.
Yes.
Do you have opinions on paying open source maintainers to make sure that their open source projects stay maintained?
I, in fact, heard that open source added over $1 trillion of value to the economy from Harvard Business Review recently.
So yes, I mean, I do have some opinions on this. I guess I have far fewer opinions on like what if somebody would like to pay an open source maintainer. Like by all means, I'm not here to tell you. I am much more interested in thinking about this from the open source maintainers because I've been involved in open source for, 15 years at this point and more. For as long as I've been involved in open source, there's been this like open question of why are more maintainers not paid by the companies that rely on them, right? There's so much value creation. Why is so much open source happening kind of in people's free times? To some extent, I think of it like time stolen away from like their other hobbies or their family. And like, so that's kind of been the question for as long as I've been involved in open source. I think you've seen different kind of generations of thoughts on this. I wrote a blog post recently that I actually wrote 2 blog posts. One that kind of tries to take a look at it from like an individual maintainer perspective, and the other that tries to take a look at it from a more kind of systems economics perspective. But I think it's really important to recognize that very frequently we have trouble articulating what it is that paying maintainers would achieve for like the payees. And as a result of that, it's hard to get people to give you money if you don't want or if you can't articulate what it is. And I think sometimes this is desirable from an open source maintainer's perspective in the sense that one of the things that comes with somebody giving you money is like probably a certain degree of expectations about like what you will do. And for me, at least, part of my enjoyment for open source maintenance is precisely that it's much less constrained, right? If I am not feeling motivated, I don't have to look at my project for weeks on end, right? If there is a feature request that like I'm not happy with the API for, I can sit on that till we find an API that we're happy with, right? I have a lot of flexibility to prioritize how I would like, and for me that makes it more sustainable. Like I think I'll be maintaining open source software a heck of a lot longer as a thing that competes with my other hobbies than I would if I was getting paid for it and feeling a sense of obligation. So I think there's a trade-off there that is sometimes unacknowledged.
Okay. I like this perspective because I definitely feel those feelings of like, this is my project and I'm not obligated to, someone contracting me to do X, Y, Z or whatever. I have more control and I have it on my time. and I'm working on it because I like it. But then we kind of fall into a little bit of the tragedy of the commons of like, you know, it's no one's responsibility to like make sure that this project that we all benefit from stays maintained and well kept. Do you have suggestions about that?
I feel like I do not have a lot of suggestions about how to address that. I think the biggest gap is, to me, is that I think we do not have a great sense of how to predict which projects have a risk to their maintenance, right? Which projects would an injection of, you know, money into actually materially impact how they're maintained? I think there's a tendency to kind of treat all open source projects as if they're kind of all very similar to each other, and I think it's mostly not correct. Like open source projects vary a lot. There's another huge problem, which is for maintainers who have full-time jobs, an injection of small amounts of money, while like it may be like very appreciative and like you can buy things with money, like actually you can't, it's difficult to buy a lot of time with like less than full-time salary replacement levels of funding. And I think there is a huge unresolved question of like, what should you do for an open source project that like does not, you would never say the subject matter justifies a full-time person on it, like maybe like a stable compression format, like that's probably not 40 hours a week of work. Like, what is the appropriate way to fund that? Like even like totally blue sky, you know, no kind of ordinary commercial constraints. Like, what's the right way to fund something where like you wouldn't say this is a full-time person's work, and you can't buy half their time because they have like a 40-hour week job? Like that, I think that pushes you towards kind of some of the all or nothing challenges that we have, and I don't have a solution to that, but I think identifying the dynamics is helpful, because I think too much of the discourse is like companies are greedy or companies are mean, and less on like what are these systemic factors and like, you know, what are the actual incentives?
Well, we do have a solution to that we can steal from Paul Graham, which is to fund open source in batches, right? Like, you can, instead of paying one person to maintain one project, you pay one person to maintain 10 projects.
Oh.
And then all of a sudden you're running a consulting business, which is why like I feel like this whole like conversation about open source is, it's like the no take only throw dog meme. It's like you can't get paid for open source. You just need to find like the open source projects that like are valuable about some amount of people, and then like work on them in exchange for money with the people that they're valuable to. This is an option that is available right now to everybody, and like we have friends who do this in various ways. It's just like it's not every project all of the time. And then you have, like you mentioned, someone asking shit from you, and that kind of sucks.
Yeah, well, I mean, I think it's important to distinguish between getting paid to work on the open source project itself versus getting paid to work in and around the project. Like, if you are the maintainer of a project and like you would like to get paid by somebody who like is a big user of it, and you know, maybe part of your time will be like upstream bug fixes as relevant, but a lot of it will be like helping people at the company use it, or like you know, making the company more efficient at using it, you know, either kind of in-house or as a consulting. Like, there tend to be like lots of opportunities to like help somebody use Python better, help somebody use Django better. Like, you can definitely get paid to do that. I think of that as being like fairly different from like get paid to work on the open source project itself. But you know, it does exist.
The help use it side as opposed to the like push commits to the project side. Okay.
Yeah, and like there are people who like, you know, square the circle by like they charge people to like teach them how to use the project or whatever, and then they, you know, take their 30 hours a week of income on that and like, and they use their other 10 hours a week to work on the project itself. Like you can certainly kind of do kind of in between solutions like that, but
I've seen what David mentioned, which is like basically a consultancy, but you like you care about the Go cryptography standard library, or these other, you know, maybe OpenSSL, but another library that people really care about. Like, we don't just work on any one of those things. We work on an ecosystem of things so that it's not just one person getting a full-time salary to, or, you know, whatever, to work on a single thing that doesn't need a lot of work every single week. by people who care about the maintenance and that may care about like, hey, we need we need MLChem in Go. Like, who's going to do it? Who's going to prioritize it? Who's going to propose it? Who's going to get it merged and code reviewed and stuff like that? Like, that seems to be a at least functional paradigm. And it's definitely not like give $10,000 every quarter to the Go implementation of MLChem that lives on GitHub. And like maybe the maintainer will have 5 hours every quarter to like, I don't know, upgrade dependencies or something like that. But yeah, it's like there's no one real paradigm that seems to be like well established of the open source ecosystem. So
yeah, and I think Filippo is doing, particularly with Go, is doing a lot of work to kind of figure out the practical realities of doing, I think, what he calls professional maintainership.
Yeah.
So like, I mean, his is the, I think, experiment and model that, if it's successful, other people will see if it's applicable to their ecosystems as well. For myself, like I said, I enjoy these things being kind of unencumbered.
Yes, me too. Because like I like my little repos that are just me and maybe some other people, and then all the other stuff involves like setting up a consultancy or a company and all that crap. Thomas.
I don't know. Just speaking of encumbrance, right? Like, so obviously, like one of the reasons we would be interested in talking to you, besides the fact that you're like one of our spiritual advisors, is that 4 odd years from now, when President Pritzker is sworn in, you could be the chief technologist at FTC, right? Like you could go back and like do that for real. And my question is, if you were in that role, if you were leading tech policy at FTC, would you support a rule that says that you can't upcharge for security features?
Would I mean, that's a great question. I love that question because I think it pits kind of two strong intuitions against each other. One is like the strong intuition that like we like security features and like we would like more people to use them, and like charging for them reduces their usage. So like getting more people to have like SSO, for example, more of that will happen. Yeah. We will get more people using single sign-on if we do not charge for it. Against the second intuition, which is that there are lots of, so like SSO is like kind of mandatory in some sense. Like if you were running like a SaaS business that is enterprise customers, like you probably have to have it. You will have to develop it. But there are lots of security features that are like basically discretionary. Like you will basically add them based on whether you think you can get new sales based on them. And like they will simply not be developed if you cannot charge for them. So like I do not think like I don't think a blanket like you can't charge for security features rule could possibly be right. I do wonder if there is not something for certain baseline features like MFA and SSO, and maybe literally only those two, where you want to push just like you. If you think about like what a national cyber, God, I can't believe I just said national cyber, a national information security goal was like, you would say like, we want like basically all businesses to like be using single sign-on, like, whether they're small businesses or like whatever, and that will only happen if we drive these costs way down. And so I would love less interventionary like policy ideas for like, how do you make it so every small business is like, Quicken account as single sign-on. I would like something less interventionary for like how do you solve that problem?
You kill SAML. That's how you do it. OIDC is cheap. SAML is expensive. Like,
I don't think that actually solves any of the problems now. I think that smart organizations already are killing off SAML themselves. Like I don't know. I find most of the discourse about this topic to be kind of blinkered. So like, one way to look at it is that people are charging for SSO and that retards uptake of SSO. The other way to look at it, though, is that, people paying for SSO is subsidizing smaller customers. Like there's really not much of a difference, right? Especially when like, I think you yourself kind of acknowledge it's the reason there's a SAML upcharge, or not a SAML, like an SSO upcharge. God, there should be a SAML upcharge, I agree. But like the reason there's an upcharge for SSO, it has nothing to do with support or cost basis or anything like that. It's a really pure customer segmentation thing, right? Like they're like the cohort of customers that you want as an enterprise, company, right? Like that cohort is almost uniformly required to have SSO, right? So like the right way to look at it is just like the account that has SSO is what the service actually costs, right? And every other account tier is not the real service.
Yeah, I think that's like just descriptively correct. Not just it's like clearly descriptively correct that there's like this is a customer segmentation mechanism, and the like free tier users who have effectively the same product are being subsidized. I think it is. If you're just like looking at it as like a policy outcome, like does it produce the outcomes we want? Like I think you get suboptimal outcomes.
Is there evidence for the suboptimal outcome? I get what I think I understand. Like if you look at the last 10 years, given the SSO tax, right? Have we seen decreased uptake of SSO as a result of it? And is there evidence for that?
I can't point you to a study, but like I have a fair number of friends who like work with small businesses, and like a lot of their customers are roughly in the position of like we are not going to spend $3 extra a month for each account for each user.
Yeah.
Or like and that's the optimistic case, right? There's a lot of SSO taxes that are significantly, we'll say, more segmented than that, and so it would be utterly shocking to me if not just on the margin but like in the whole, like there was not significantly reduced single sign-on. Like I said, I would like something less interventionary than like it's illegal to charge for this, because like I think if you make it illegal to charge for this, you get less of it. Right, like that's kind of like economics 101. So like I am far more interested in like what are holistic policy changes one could pursue on like how we kind of price the externality of bad data security than we have right now, and like kind of let the chips fall where they may on terms of like what protections companies choose to like implement. Like I think right now you have this problem of what is the cost of bad security is maybe very difficult to predict. It is the through line between like, if I don't do this, I will have a breach of this severity, and like what will my punishment for that breach be is insufficiently predictable for people to invest intelligently.
And I hate that, but it's definitely true. It's you can make an argument that this could be very, very bad, like a breach that happened over there to a similar person in your market share with a similar size customer base with similar kind of data, but you can't like deterministically with any kind of confidence actually say that.
Yeah, even
Especially,
if we. Oh, sorry. I was going to say, even if we stipulate, like, I will have, if I don't do this, I will have a breach. Like, what will the consequences for my breach be? Are I think far too unpredictable. So I think policy that better forces companies to internalize costs of bad security are like much better. And then like we let the chips fall where, right? Like let that incentive guide how companies choose to invest. If they still don't want to buy SSO, they don't buy SSO.
What's an example of a policy that internalizes those costs as opposed to externalizes them onto users?
Yeah, so the policy I'm very interested in is basically a strict liability regime for data breaches. So like we've got like basically a law that says kind of strict formula. If you have a data breach, like we look at how much data was breached, like what types of data elements, how many rows of data, and then like here is the price for this. It's close to trivial to go into court and get that penalty. There's some really a cool economics paper from I believe George Mason University in the Michigan University like Law and Technology Law Review. For David,
Go blue, of course.
But and like they run through kind of the economics of it, but like basically the thesis is if the company knows what it will cost when they have a breach, they know better than anyone else what kinds of safeguards are likely to impact their risk. Like they know way better than some like external regulator does. Like what will be good for their company, and if they know what the price is, they can act efficiently. It's like basically the core thesis.
What if imposing an SSO tax is like a multiplier on a data breach or something like that, or the lack of phishing-resistant authentication?
Yeah, I think there's probably lots of like interesting variants. Like from you didn't have the security mechanism. I've also heard people talk about, if the data is really old and like you didn't have a good reason for retaining it, like that's some sort of multiplier. I think lots of these are like potentially very interesting. I think about two things. One is just like how administrable is the system, right? Like, is it predictable to the end user, and is it straightforward for like a government agency to actually bring cases based on this, right? Like, you don't want the situation where like bringing these cases like takes a lot of staff time, and so like you kind of only do it sometimes. Like that is inefficient from like a company's pricing their risk perspective. The second factor I think about is like, I think probably all of us on this call and like probably all of the listeners have like an incredibly strong intuition that like phishing resistant MFA is like off the charts good, like ROI in terms of reducing your breach risk. The concern I have is like if you put that into law somehow, is you get kind of a distortionary effect, right? Companies have a stronger incentive to patch that risk, they do some other risk. So like, if you let's say we put a 5 times multiplier, a huge multiplier on no phishing resistant MFA, then somebody has an incentive to do that, even if there's something else that has 2.5 times higher risk of actually happening.
Yeah.
So like you get these distortions, and like maybe sometimes you kind of want that distortion because it causes the entire market to coalesce, right? Everyone always has WebAuthn, and the ecosystem effect is like worth that.
Yeah,
but
it
I
smooths
think
out. The consumers are more used to it.
Right,
like
employees. Yeah, right. Like clearly, maybe. I don't know, clearly. Sometimes it may be the value of the ecosystem effect may be worth the distortion, but I guess I am nervous about, reaching for that thing always, right?
Sure.
I think the best incentive is like when companies are, they care about the on-the-ground realities and not kind of the 50,000-foot view of like across everyone, right? I think we've all probably been in the situation of some regulatory requirement or some policy says you need protection X, and you're like, this protection makes zero sense in my context. Like, why are you wasting my time? And like the answer is like that person is like, in the best case, that person's like, yeah, in general, like I get it doesn't apply to you, but in general, we want everyone to have this because it's just easier to manage our across-the-board risk that way. But like as a person in that circumstance, you're incredibly frustrated that like you're basically being asked to spend time on things everyone agrees for you are not good use of time, even if for somebody else they are.
Yeah.
And like you don't want. I think that's a very bad kind of. I don't think people really talk to. This is a bad user experience for a regulation, right? That is a form. That is an experience that will breed resentment to the regulation.
That makes sense.
Bad RX.
Yeah.
So when you look at SSO.tax, where
Yeah.
do you see a wall of shame or do you see a leaderboard?
I do not see a leaderboard. I mean, I have also been
Leaderboard.
I've also been the guy responsible for security at like a small to medium-sized company, like frustrated that like I was going to have to justify, some budget difference because like we were trying to take security seriously, but we were also like small. So like I think by far the best outcome is for companies to give a little bit, right? Have the free tier that's, your Okta and your G Suite OIDC, right? Like find the slice that like still gets you most of your customer segmentation, but like give a little bit for free. Like that, I think that's just such a pressure release valve for any sort of policy intervention.
That's basically what we do is like Google and GitHub for free, and then if you want to do something else.
Yeah. And like, when we talked about competition at the start, I worry about like encouraging only the largest OIDC providers, but like, that's the best compromise I've got standing here today.
But
I like
that's also
discouraging
not-
people. I like
Yeah.
discouraging people from using small OIDC providers.
Yeah, because like I'm like, you don't support Okta, and I'm like, yeah, I support Okta. So. Okay, last thing. Can you tell us about this little website that was very popular in late 2020 that scraped the New York Times poll results
Alex
data?
News Network.
Yeah.
Yes. So people with long memories will remember the 2020 election did not end on election night, as is kind of traditional for almost every American election.
Or at least abstracted that way.
Yeah. So a thing that was created, I think several of you contributed, was we basically made an alternate viewer for when we scraped the New York Times data every couple of minutes. We put kind of the raw kind of election result data in a GitHub repo, and then we had a HTML page that rendered it out and had what at the time were some novel statistics. I think was the important thing. The most important of which was the hurdle, which was a measure of what of the estimated remaining votes, what percent? Yeah, the remaining votes to be counted. What percent would the current as counted, the second place candidate need to capture in order to win? And an important fact about the 2020 election is because of different state laws, there was a really high correlation between vote counting order and partisanship.
Yep.
You had states that counted their in-person ballots and their vote-by-mail ballots kind of basically in different orders.
Yep.
And so this hurdle was like a really effective way to see who was, how close the race actually was. Because you'd have races that were like 50% counted, and basically like where they were at 50% was very, if you just looked at the raw numbers, was very unpredictive of who was likely to win in that state. So we kind of put this thing together over the course of election week. Many folks contributed. It, I think, kind of went viral on the internet. It was, it was a useful experience. I think we got a lot of positive feedback. My personal favorite was like a local Georgia news station emailed me to say like this was like incredibly useful to our like local election coverage.
Yeah.
And that was great.
And of course, Georgia was one of the ones that turned blue, and it was like a whole big deal. And then eventually they had like Senate runoffs and a bunch of other shit.
Yeah. Georgia was one of those close states that took quite a few days to count. We had kind of GitHub issue tracker where people were filing issues. My personal favorite is somebody files an issue and they're like, I don't really know how to program, but here is this like LaTeX math paper explaining why like your hurdle calculation is wrong in the face of third parties. And it's like fantastically worked through like math problem. And so like it was a very kind of positive experience. It was a much better thing to like throw yourself into like building this thing than like actually refreshing the New York Times website. Like this was much healthier.
Yeah. And I think New York Times and maybe other election tracking sites like borrowed the whole hurdle notion, or they might have called it something else. I think it whatever they called it, but like it literally showed up and it was not anywhere before your thing.
Yeah. When the New York Times had their pages for those Georgia Senate runoffs, they also had kind of the hurdle metric. I don't know if we've seen it in elections since, now that there's, we're not kind of in peak COVID. There's not that kind of correlation with vote by mail. I believe the hurdle was your invention, Thomas.
I remember. I don't have much more to say. Like I was wondering. I sometimes wonder if I invented it, or if somebody, like, if we were just talking about it all at the same time. But I remember it, and I like the hurdle.
Yeah.
I also seem to remember that like at some point we got some like a screenshot of like a MySQL database at GitHub that showed that like the GitHub pages for the Alex News Network was like far and away the most popular GitHub pages like ever thing.
I do not remember that. I do remember, at one point we built a system where like the page would like hit the GitHub public API to like know if there was new data and automatically refresh. Yeah. And like we definitely got somebody who showed up and was like, "Hello, I am a GitHub SRE. Like you are melting this API. Like you are some outrageous percentage of the traffic to this. Like, can you please like hit this other endpoint that's like cached?" And we were like, "Oh yes, we can do that."
So yes, we will gladly hit the read through cache.
Yeah.
Like, thank you.
Yes.
We didn't know about that one. No, I remember that, and they were just sort of like, hey, because like the first versions of the website were really, really dumb. It was literally just like it would scrape it and it would like reload and hit GitHub like every time. And like we were using Git as like the index for the database, like, or whatever, the database. And then it became smarter and better architected as it became a little bit more popular.
Yeah, and like I was satisfied with the product experience of like there is a TXT file and I run git log to like see the revisions, but like wiser heads prevailed and like there was an HTML with like a table element and like that was better.
Yeah. Well, we just wanted to like let the people know that if they ever use that website in the the stressful days of November 2020, like that was basically you that made that work, and we all just jumped in and scurried around.
I think my lines of code, I wrote a tiny fraction of that. I get credit for starting the GitHub repo and maybe helping project manage it a little, but I think a lot of other folks did almost all of the work.
Yeah, well, we call it the Alex News Network for a reason. So, all right.
Well, Alex, thank you very much for joining us. And we'll not talk about what you're doing next, but we'll assure all of our viewers that you're employed and you've missed your opportunity to hire Alex. So,
well, thank you for having me. This has been a lot of fun.
Thank you very much, Alex.
Security, Cryptography, Whatever is a side project from Deirdre Connolly, Toast, Tatchuk, and David Adrian. Our editor is Nutty Smith. You can find the podcast online at SCW Pod and the hosts online at Durham Crustalum, at TQBF, and at David C. Adrian. You can buy merch online at merch@securitycryptographywhatever.com. We're also available on YouTube now. If you like the pod, give us a 5-star review wherever you rate your favorite podcast. Thank you for listening. Bye.